axis is. Okay, period. Okay, so once you locate your neutral axis, the analysis is quite simple. Okay, so that is the most important factor in week 8. Okay, I mean you still need to know how to do your calculate your shear force or your shear stress. Okay, that is still required. So that's week 8, and then how to combine them into an element. Okay, so that's for week 8. Now combining them into an element, I think is straightforward. The thing is the shear force. Okay, the shear stress. So the shear stress, so like for this case, the shear stress are from two different direction. Okay, all you need is to see which one is the higher value, and you follow the direction of the higher value. This is what you have to take note. Okay, so this is for week 8. Okay, so week 8, if you look at the topic, is regarding combined loading. Okay, then we are going to go into week 9. So week 9, we still carry on our example on combined loading, and we started to draw Mohs circle. Okay, so week 9, we focus on 2D Mohs circle. As you can see now, we have done so many problems with Mohs circle. Like today's quiz was so straightforward. All right, I can see you're more comfortable in Mohs circle now. Okay, so Mohs circle, the most critical thing where a lot of confusion come is the shear. Okay, the shear clockwise or anti-clockwise. Okay, because it will affect the position of your point X and point Y. Okay, a key thing to take note is on element it is 90 degrees, on Mohs circle is 180 degrees. So I test this to you guys in the quiz. You guys do seem to get it. So we talk about positive shear and negative shear. The thing to take note is how the element is deformed. Okay, so like for this case, the one that you can see now, right, point Y, right, you can see point Y over here now, right, it is down here because based on this force, shear force that we're looking at, or shear stress, the element is going to rotate in a counterclockwise direction. So this is counterclockwise. Okay, so that's how you locate your position of your shear stress. So we did Mohs circle, right? So Mohs circle is pretty straightforward. The thing regarding the principal stress, you can take from point X, okay, point Y. Okay, the rotation is in the same direction. Okay, so does not matter. I want you to be comfortable. Drawing the element. Okay, so we did from element to Mohs circle to bring back to element. Okay, so for this case, we brought back to the Mohs circle to element. One tricky feature, not tricky, intricate feature is what if we ask you to rotate the element by 30 degrees, right, from point Y. So from point Y 30 degrees on the element on Mohs circle, it will be what? 60 degrees. Okay, so 2 theta, and the direction is the same. So over here you see the direction from Y to the plane is in a anti-clockwise direction. The Y to here is also 60 degrees in the same direction. Okay, only twice the angle. Then the tricky part over here is the direction of the shear stress. Okay, so if we look at Y30, if we can focus on Y30 over here, the element rotation is anti-clockwise. Okay, so for anti-clockwise rotation, Y30 has to be in that direction. The normal stress, usually a lot of you don't have the problem, is the shearing stress is the issue. Okay, so this is on 2D Mohs circle. Then we did briefly, okay, 3D Mohs circle. Then the next thing that we take into consideration, we go into design, okay, theory into design of a transmission shaft. So when we do a theory and design of a transmission shaft, okay, this analysis is without axial load. Okay, so whenever they say it's a transmission shaft, you have to not consider the axial load. Okay. Then we did some derivation which we did not finish. Okay, so that was week number 9. Then we go into week number 10. We go into detail, okay, regarding design of a transmission shaft. Okay, so we ignore the axial load. Okay, we ignore the axial load. So now, why is it we have to consider the radius of the circle? Okay, or consider tau max, because a transmission shaft is usually filled in shear. Okay, so in this context, we derive a formula. Okay, we derive an expression over here. Okay, using Mohs circle theory, that the radius of or tau max is equal to C over J my squared plus square root of my squared plus by mz squared plus by torque in the x direction. So you can see down here, there is no axial loading at all. Okay, if there's axial loading, okay, you cannot use this formula. Okay, regardless how small the axial loading is, you can use this formula. Okay, this will not work at all, right? Then we found we rearrange. We can find the radius of the circle. Now, this is where, if it's given a system like this, okay, usually we have issue with system integration. When I say system, is where you have a driver and you have a driven. Okay, so the motor gear is the driver, the gear A and B are the driven. And always remember, right, the gear A, the driven gear, will always resist the driver gear. So what do I mean? Okay. So if the force is generated to the driver gear, so on top is the driver gear, right? It's going towards the right, right? The driven gear will resist, right? It cannot be the driven gear follow the direction. Yes or no? It does not make sense already. Means the driver and the driven are helping one another, so you have more power. No, it always resists. We get confused is because we look at the rotation. Oh, they are rotating the same way. They no, not like this. Okay, so if it's not relative to the rotation, it's relative to the force which generate the torque. Okay, so that's the key feature over here. Okay, then we started deriving, or not, we started proving this concept. We apply to a gear system over here, right? So if you watch the video, we go through how, like for this case, okay, for this case, right? So the first thing you have to do is you have to know where the contact location is. Okay, so what do I mean by contact location? You know that this is the contact location over here. This is the contact location, and that's the contact. So identify the contact location first. Why you have to identify the contact location? Because it will dictate whether it is in the Y or in the Z direction. Okay, so now if EY, so EY is your driver. Okay, your driver. Oh, EY is your driver. So if the driver is coming down, right, dy or dz over here, it does not make sense that it's in this direction, right? Because it's going to follow, it's going to help ey, yes or no, in terms of rotation, in terms of torque, right? So that is why it has to oppose the direction. Okay, same like C in the Z direction. Okay, so this is where it's important. So identify the contact point is important, number one. Why the contact point is important? Because if you don't identify the contact point, you don't know whether is it dz or is it in the Z direction, the reaction, or is it in the Y direction. Okay, so for this chapter, I think this is the critical part. Okay, I think the quizzes, I did not test you guys this yet. is I gave you the direction, or the question gave you the direction. Okay. Then from here you set up, you find the reaction at the ball bearings, okay, at position A and at position B. So remember, we have two directions, right? You have Y and Z direction forces, okay. Then you resolve your forces. Then from here, you start calculating your torque, okay, or your forces. Okay, so important thing to take note is power is equal to 2 pi nt divided by 60, right? So you given power is 2 pi nt times 60. This is your torque, okay, and then your force is torque times radius. Okay, that's the formula that you have to remember, or in your summary sheet, make sure you write this to help you in your term test or your exam. Okay, then from here you calculate the reaction using static analysis. Now you guys are really good in static analysis. Then the next thing is calculating moment. Okay, so you have to calculate moment in the Z direction. Then you have to calculate moment in your what? Y direction. Okay. Then you have to calculate your torque, right? So like for this, torque is where some students get confused. So from A to B, A to C is 0, right? C to D, right? You have 397.9. So this is your value. Now this value 198.9 is you have to add up. Okay, you don't come down. Okay, this is not absolute value. These are all relative value. You have to add them up, and then it has to come down. So at the end of the day, when it reaches your ball bearing side, it has to be what? 0. If you look at all the questions I've given you, they are all zeros. Okay, then you tabulate. Okay, you tabulate your moments at different position. Then you apply my squared plus my mz squared plus my torque in the x direction squared. You find the highest value, okay, which is at point D. Why you calculate why you use that? Because likely any point will fail. It will fail at point D. Period. Simple. Okay. So from here we just plug into a formula. Then you get your diameter. Okay. As I say, design of a transmission shaft is solely a mechanical engineer responsibility. Okay, it's us. Okay. Then we look into principal stresses. Okay, in beams under combined loading. So this is pretty straightforward. Okay. The only thing that you have to remember is that failure will occur at this junction. So whatever you do, when you calculate failure at, okay, let me highlight exactly where better. It is this region that failure will occur. Okay, so either you use thick wall or thin wall, does not matter. The results will be the same at the junction. Okay, so and when you calculate your moment, you also calculate your stress due to bending moment is also at this position you have to consider. Okay, so from here we move into week 11 or tutorial 10. No, tutorial 10 is straightforward. Lecture 11. Okay, right. Okay, so we have to form the shear stress and bending moment equation. Okay, if you have a lot of confidence about drawing the shear force and bending moment, okay, you don't need to form the equation. When I was teaching, I want you to be aware, and also when I was teaching this topic, I was thinking about elastic curve method, because elastic curve method you have to form the equation. Okay, so since now elastic curve is not considered, yeah, but it's okay, it's good to learn. Okay, so over here I focus quite a lot on writing the shear force equation and the bending moment equation. Okay, now for this example, the most important thing is where are what 2 points. Okay, what points are you going to look at? Okay, so you have to be very intelligent, okay, about choosing the points. And in the term test